discuss with you is you guys, we are on the 5th week. The next week is our reading week. It's a good time for you guys to take a little bit break, no classes, and get some rest, but not too much. So because I guess following the reading week, there are some midterm exams. So my advice for you is to go to the reading week with a plan. So have a clear plan on when am I going to take a rest, and on those 5 days or whatever 5 days or 6 days, here is my plan. On that day, I will do that assignment. I will review this course and so on. So please have a clear plan before you go to the reading week. It is going to be very, very helpful for you. So tied into the reading week, we have a midterm exam. So I'm not really very concerned about midterm exam in this class for a very clear reason. I do have only one midterm exam, not two. That's unlike design courses like structural concrete and structural steel and soil mechanics and strengths of material. I only have only one midterm exam. That's why I'm not worried too much. I will just relax a little bit. When you come back from the reading week, we will have to cover some material. Then there is an assignment. Once those assignments are marked and back to you, then we can set the midterm exam. Also tied to the same discussion, which is assignments. So I know that probably not you guys are not really happy with the the marking the assignment. I know that so far you guys are working on 3 assignments. You submitted 2, and there is the third one is I think due to Friday midnight this week. And I think I made it. I think if I'm not mistaken, I made it even sometime on the reading week, probably Tuesday. You can correct me if you wish. I think it's Tuesday of reading week. So I give you some time, even you're not able to catch up with the assignment, then you can work on the assignment on the reading week. However, I know that I haven't marked anything so far. There is a kind of a big backlog on me, and I need to finish it. But here is the promise. The promise is on the reading week, I will just same thing. You guys are busy reviewing for midterm exam. Also, myself and I guess many instructors will be busy marking and clearing up all the marking log. Here is the point. So I will not really test you on midterm exam while I haven't marked it and give you enough feedback and time to look at the material one more time. So that's something I promise you this is going to happen. So then when you look at assignment number 3, I need to talk a little bit about assignment number 3, which is already released. I think that was on Friday, sometime on Friday. And again, the due date is on Tuesday of the reading week. So probably from now, I guess from now it's one week from now. Okay, so the assignment, as you can see, I will share my screen. Sometimes I forget to do so. So here is the assignment number 3, which comes in 3 questions. Question number 1, which is simply manually creating contour lines, manually. And when I say manually, I'm not asking you not to do it using AutoCAD. If you are very well skilled in AutoCAD, fantastic, do it please on AutoCAD, but don't use Civil 3D to create contour lines for you. So you want to do it on a piece of paper, great. You want to do it on CAD, great. Okay, both of them are acceptable, but please don't use Civil 3D. You can use Civil 3D to check it, but not really for submission. And you can see here there are a few points are given, and if you want to do it on a piece of paper, then you have to, first of all, you have to draw those grid line on a piece of paper to the given scale. And remember, the size of the cell is 30 meter by 30 meter with a scale 1 to 1000. So this should measure on your paper. Every cell should measure 3 centimeter by 3 centimeter, and then you repeat those. Then someone asked me, Tahir, do you want me to show you a calculation like all the numbers? you know what? You can show me a sample from every line. For example, two calculation for a contour line number 90 and 98. Remember, you are not required to create all the contour lines. That is too much work for you. I understand the time it takes to create a contour line, and that's why please read. And I want you guys, when you read assignment, please read carefully, because there is a lot of question that the answer is in the assignment itself. So you can see here I'm asking for only two contour lines, which is 90 and 98. Don't draw all the contour lines. Only 90 and 98. And please show me only sample calculation. Like how did you find 2 points on contour line and 2 points on contour 98? The other thing is, please don't try to connect contour line outside the data. So if you have a contour line in this area here, don't, because extrapolation is wrong. We don't know. So don't do that. Just draw the contour line within the given date. Now, question number two, it's should be also straightforward. It is very similar to what we've done in class, where you need to import some surveying data, create a surface, uh, to change the style and customize it to your needs, add some labels for the contour and some spot elevation. So there is nothing super in there, okay? And even for printing, I already create for you a layout where it has a title block. You have to do a very minimum, adding the north arrow and stuff like we've done in assignment number 2. Now for us, for question number 3, which is I think it was troublesome for some of you. So in question number 3, first of all, I'm not asking you to create a different map. Watch this. I said here on the same map created for in question number 2, which means don't submit for me two different maps on the same map that you have created in question number 2. Do the following. Number 1 is check the intervisibility between points A to B and A to C and E to D, where A, B, C, D are those are the coordinates. I already saved you some effort. So, you know, if you already started on the assignment, I saved you some effort where I give you these coordinates in a data file. So if you download the data, there is a file called extra points, and this file contains A, B, C, D, and also point E here. So you can just import them and you can check visibility right away without having to manually type in. So the only thing that I got from students is they said, you know what, Tahir, every time we're trying to check the intervisibility to point D, it doesn't show, like the arrow doesn't show. Did anybody in this class had the same problem?
It shows to me.
Actually, look at this, please. So before I release my assignment, I checked it, and you can see here to point D, everything is okay. Here is the point. To be honest, I cannot figure out why for some people it doesn't work. So as you move your cursor and try to click on point D, simply sometimes the arrow just is hidden, doesn't show. If this is the case, please try to do it as close as possible. So move your cursor a little bit right and left until you see the visibility arrow or the check. Are you guys following? You can see here everything on my screen is working. For point A, B, and C, it's okay, it's visible. How about for point D? There is a blockage for this line of sight somewhere here. Okay. So again, bottom line is, if this arrow doesn't show for point D, please do it as close as possible. And simply, that's really what I wanted for the assignment. It should be straightforward. If you attended the class and did the training, you should be able to do 100% of the assignment. So some of you, the last thing, some of you ask me, okay, so what is my final delivery? Should I give you CAT file or should I give you what? Really, what I'm asking you at this point of time, to submit a PDF file. And I know some of you will do this as one PDF file, so you can print a PDF file for question number 2 and question number 3. And if you've done this manually, so then you can scan your hand sketch, your sketch, and you know that has the contour line. Bottom line is, if I have so many PDF file, can I combine them in a single PDF file? What do you think?
Yes.
Yes, you can. Okay, so that's why. So for me, to be honest, like over the years, I discovered when I just don't limit the number of PDF file, some students they are not really educated with how to combine files, and I get flushed like lots of PDF file, and that's why on the submission I limit the submission to a single PDF file where students will have to combine all of them in one file and submit only one PDF file to me. Hopefully you have clear instruction to submit your assignment properly. Any question for assignment number 3 so far before we start today's class? Let's see. Luca.
I think Matthew was before me.
Okay. Thank you so much. Okay, Matt.
I was just going to ask if you could go over how to change the label styles, like for question 2.
You mean the contour lines?
So yeah, like for like spot elevations, or like if you label your contours, the major ones, how to change
Hey,
stuff.
Matt, I don't know if I'm going to be mean if I tell you that this was on purpose. So the thing is, yes, I am teaching you a little bit about Civil 3D and try to give you kind of good foundation for Civil 3D, but also intentionally, I want you to go and play, enjoy, try to figure it out, okay? Because this figure out process, it will teach you something, okay? So please don't think of me as a mean instructor, but that was intentionally left for you. You need to figure it out and use resources. Search, for example, YouTube, find the resources. It's not going to take 1,000 hours to do that, but it's just a learning process. When you graduate and Tahir is not around the corner, you need to be able to find the information on your own. And again, I'm hoping that in my class we do some training and it gives you kind of a key or clue on where to go, what to do. And if you cannot, then ask me and I will help you out. But just try to do some effort on your own. Hopefully, this is not a bad response for you. Okay.
Okay, sounds good.
Okay, then Luca.
For the spot elevations, do we have to follow your instruction that you told us in class?
Yes, please.
Yeah,
You
okay.
can. Okay, go ahead. Sorry, I have to. You finish your question, please.
Yeah, no, I mean, you didn't give us specific points to where to put a spot elevation. We have just to follow your instructions that you told us in the last class.
Okay, thank you so much. So Luca's asking, where should we add spot elevation since there is no direction on the assignment on where to add the spot elevation? So I said before, guys, here's a couple of things you need to notice before we continue. Number one, please, I don't want to see anybody submitting the map this way. You can see, I can see my contour line and I see my data. And as I think I discussed with you, the data is not required. So you want to turn off the data. And I know some of you until now struggle to remember how can I turn off my data. So the way you do it is you go to the point group properties, then you choose here a none for both the point label and the point style. You can see here, so my data, surveying data, is not there anymore. Number two, Loka is asking, where should I add spot elevation? I said it in the class. I said, I feel very bad when I ask students, add for me spot elevation, and they go this way. They go, okay, here is my surface. I click on it, I go to label, add spot elevation, and this is how you do it. 1, 2, 3, 4, 5, 6, 7. Okay? That is not correct. Spot elevation are added for a purpose, and the purpose is to remove confusion. For example, when you look at this here, it looks like what happened. It looks like there is a confusion. We don't know if this is a depression or a summit, where as soon as you place here a spot elevation, this will tell you right away that this is a summit. Also, along the border area, like this area here, looks like there is a confusion. We don't know. So we place a spot elevation. So the answer is very simple. Every time you see a closed contour line, then there is a spot elevation. For example, like here, okay? And every time you go along the border, and every time you have a confusion, like here, for example, then you add the spot elevation. Did I answer your question, Luca?
Yes, thank you.
No problem. Any other question before we look after our discussion today? Okay, then.
Quick question for you. I uploaded both of those point things that you gave us into one file. Is that a big deal? Do you know what I mean?
So I mean, look up my tool space, please. Is that what you've done? Like you brought the two data sets, so because I gave you two files, one for the data and one for the extra points.
Yeah, so when I uploaded them, just clicked both of them and labeled it as one file. I should have obviously made two.
You know what happens? Those points those extra points, the 5 points, they have no elevation. And so what happens? You will not get the same contour lines because simply some of the points will have 0 elevation, and those are not really a surveying data. These points, I want to check the visibility between them. So you can do what I did. You just import them in a different point group, and when you create your surface, do not include those extra points in your surface creation. I'm hoping you haven't done this.
Yeah, I definitely didn't do it the right way the first time and got a decent way. Is there a way of like extrapolating them out now, or do I have to restart?
Sure. I can give you a help for this one. So all you have to do is go to your data, and remember your data right now, it has those files. Those 5 points. Okay? And then what you do is watch this. So as you click here on the point elevation, you click on this column here. And you know what happens when you click on the column? So simply the software will sort all the data based on elevation. And since those 5 points, they have 0, they will come on the top. And then once they come on the top, you just have to mark them and then right click and then delete. Okay, when you delete them, what happens is you will see there is something is going to happen. Your surface will get this yellow triangle. And you know how to remove this yellow triangle, huh? We've said it last class.
Yeah, update your surface or right click and
then what you have to do, you can take those 5 points out of your surface definition, then you can import them one more time, but in a separate point group.
Okay.
Is that clear?
Awesome. Thank you.
Amazing. Okay, now we will start our class today, finally. Okay, so feel free again, even if you don't follow the discussion and you have any question, although this creates more effort for me, but you still have question about assignment number 3, and you had a nap while I'm discussing assignment number 3, just email it to me. Don't text me on MS Teams, okay? Now, today's discussion is about one very important topic in civil engineering, which is about cut and fill, which we call it sometimes earthworks. I can tell you every single project, and I'm very confident, every single project in civil, it will have some sort of or some amount of earthworks. You will have to move your soil left and right, north and south, until you get your project done. Okay? Sometimes the soil work is too much, and sometimes it is too little. But I can promise you, in every single project, you will have some movement of your soil. Okay? Some project it involves, it's basically the earthwork is the main budget item, and sometimes it is not the main. For example, if you talk about road construction, what do you think? In road construction, yes, there are some items like asphalt and some items like, like lightning. However, or lighting sometimes, but soil work is too much money. Like, for example, I remember when I work with the West LRT, and the West LRT goes from downtown and it goes all the way to the west end of the city. And if you have taken the C train to the west side, you will see it goes initially from downtown on grade, and then it takes a series of bridges until I think you hit boat rail. And then on boat rail, it goes on grade, and then it goes into a tunnel into Westbrook Station. And then from Westbrook Station, it goes into an open trench parallel to the 17th Avenue Southwest. until you go on a bridge on Sarsi Trail, and then it goes back on grade, and it goes back on a tunnel. So you can see it's just combination of tunnels and open trenches, lots of excavation. So there was lots of money when it comes to the West LRT. Other projects which may you think, no, it doesn't have any cut and fill, like high-rise building. High-rise building, as we discussed early in our class, every time you build a high-rise building, you need to maintain parking or barricade for the user of the building. It is very, very expensive to go horizontally because there is not enough space around the high-rise building. So what it's typically done is we build the barricade under the building, okay? And so to do that, you must excavate down and make a big hole in the ground. Tunnels and mining, that's a main thing. When you create a tunnel or you do a mine, then lots of excavation. Dam construction, when you build a dam, so there are some different kind of dams. One of them is just by making an embankment of soil, so that contains a lot of fill. Flood mitigation, when you build some diversion channel to take the water and throw the water somewhere else. Then also there is some earthwork, storm bond construction. So you can see the list can go on and on and on and on to show you that almost every single project in civil engineering will contain some sort of earthworks. As I said, the earthwork sometimes it's a main budget item. So probably 50–60% of the money goes into soil work. And sometimes not that much, sometimes very little. I want to mention something, and this statement will probably look not 100% clear, and it will probably during the next 4 hours or 6 hours, it will look a little bit clearer. The quality of the earthwork estimates depends on 3 factors. Number one, which I bet all of you guys can guess that, it depends on the quality of the surveying data. So I need to do all the surveying the right way. I have to get the right instrument height, the right reflector height. I need to center my prisma head to have to make sure road is vertical. So all things that you learn on the first year to get a precise measurement of your 3-dimensional data. So that's one thing, but that's only part of the story. What people don't recognize is that this is not the only factor. And by ignoring the other factor, they end up with bad results, although they have a very good quality data, surveying data. And that's what I will try to emphasize during the next 6 hours. One of the main other factors that controls the quality of your final estimate is the method you use for calculation. So you will see we can use one method or another method. The choice of this method will give you slightly different results. I will control the quality of your results. In addition to the method, so every method comes with some assumptions, as you will see some of them today. Your assumptions of calculation will also affect the quality of the results. As I said, maybe now this statement is not perfectly clear, but my hope is after those 6 hours of discussion about earthwork and different methods, you will get to know. As I said in red here, more details will be given within the solved example. Now, before I start the calculation, and this part here, it has lots of calculation that is unlike the discussion we had before, probably for 2 weeks, which is focuses on, about surfaces and, civil 3D. And so the work is done primarily by the civil 3D. We go back here now and we do a lot of calculation. So this part here of the course, you will do some calculations. Now, before I start showing you the calculations, I have few projects here in Calgary just to show you the importance of the cut and fill. And again, it happens in every project. One of the projects that I have seen, we work in West LRT with the big contractor for cut and fill or moving earth called KLS. If you are interested, you can visit their website. They do a lot of cut and fill big project on a larger scale. So one of those interesting projects is 17th Avenue Rapid Transit. You guys know that recently the city of Calgary extended the transit to the east side of the city, where the transit will go, the buses will go from downtown and go quickly to the east side along the 17th Avenue Southeast, going to, I think, Chestermere. Okay, so to do that, I think they needed to do some crossing for the river, and they have to do a fill here. And the amount that the report was roughly about 120,000 cubic meter. Again, there is a link here in my slide to take you to the company website, where what they do is only cut and fill, moving soil. And those, by the way, so you know, those are the main contractor for the West LRT for cut and fill. You know, if you have lived in Calgary here in 2010 and you went to the west side of the city near Walmart or where West Brook Station is, probably now you know where the station is, West Brook Station. So the entire station was built underground. And if you've seen this big hole 10 years ago before they fill and built the station and backfill, it was a huge hole in the ground. Right now, it's kind of a parking area, and also you have like kind of some landscape. This time, it was just a big hole in the ground. Now, the second, quickly, the second project here, it's a project not in Calgary, but in High River. It's something called the Women's Colley Dam, and this was part of flood mitigation. In 2013 here, if you have been in Calgary in 2013, we had a flood, and it's simply the city was in disaster. Like, you know, bridges, they were swapped away, and even the area southwest of Calgary, it was affected, which is High River. So High River, there were houses flooding, like houses moving with the river. And that's why you know, the government, they have done some flood mitigation where they had to create some diversion channel, and they have to install some pipes to take water from one area to another area without flooding the city. Again, another big project. And then the third one here, which is the last one on my slide, it's a project, I think it's still working until now, but I think they finished already the cut and fill phase. It is called Aris Tower, which simply the Aris Tower, it's in the East Village in Calgary. And there is a 3D, like an aerial view, and this is the location of the tower. And to put things in perspective, this is our library. So this is Calgary Central Library, and it's to the north of Calgary Central Library. There is big project, big complex. It's going to be, I think, the highest residential building in Calgary by the time it's finished. Okay, so you guys remember that we had the same discussion probably a month ago when we talked about, you know, for deformation monitoring, and when we build those retaining walls and we keep excavating until we go to the right elevation, then we build our structure up, and then we simply backfill. Okay, so I'm not going to repeat myself here, but this is another example on how earthwork is being part of any civil engineering project. Now we are going to start right now, right away, without going into theory. I'm going to teach you the theory together with the solved example. And I think this is kind of different than what I did before. So I have here a few example, numerical example, and probably during the reading week, I will provide you with more examples by numbers. And so before I start, you will see as we progress in our course, this part, you will see we have different methods to find the cut and fill. Some of them, it is based on profile, so we can simply extract our cut and fill from profile. Some of them, we have to find our cut and fill from cross sections, and some of them, it will be based on grading. So I'm going to start here, and as we progress, you will get to know what are the cases or when we can find the volume from profiles, and when we can find the volume from cross-section, and when we can find the volume from grading. Let's start. So here is our first example. Our first example is we're trying to build a sewer line. Sewer line, okay? So here we go, sewer line. That's our first project. So there are some information that is given to you in this numerical example. Number one is the length of the pipe. It's just 150 meter. The pipe diameter is 1.25 meter. The sewer invert elevation, and if you don't know what invert is, please wait. It's an elevation on the pipe. At the start is 108.4. The sewer slopes down by 0.4%. Another information. Last information is the trench sides are kept vertical by means of excavation, by means of shoring and bracing with a 0.25 meter clearance each side. Now, before I show you what every piece of information means, I want you to understand that this information is not really a surveying information. I'm asking you in surveying, do we decide the slope of the sewer? No, we don't. That's not our business in surveying. Maybe you yourself in other classes, you will learn if you are part of the municipal section or options, you will know how to find or how to decide the sewer slope. Really, all those information you see here, those are not really surveying. I will make it clear. I will box them out. And that's why, please don't ever think that in my course, you will be asked to tell me how much should be the pipe length or how much should be the pipe diameter or how much should be the pipe elevation. That all the information will be given to you. Those are design information, not surveying information. Really in surveying, what we do is we do this. So this part here is a surveying part. This box here, this is surveying part where we measure the elevations along the center line. So please think about this center line here as a plan view. And we're able to measure the elevation of all these points, every constant distance between the points. For example, we simply measure the elevation at the start of the pipe, and then after 25 meter, we measure the elevation of the ground one more time, and so on and so forth until the end of the pipe at 150. So those numbers in red, all of them are existing ground elevation. How about those numbers in black where it's kind of weird? It says 0 plus 0, 0, 0, and then 0 plus 0, 25, and so on all the way to 0 plus 150. We call them station. And I know the word station is kind of new for you because you guys are not municipal section or option, and that's why you are kind of unfamiliar with those with this name. So I wanted you guys to think about station as equal to distance. But distance is not straight. Distance measured from the start of your project. However, it is not a straight distance. It's a distance along the center line of your project. In this example here, since my pipe is a straight line, then it's the same thing as distance. However, in general, station applies on road, where on roads you have a straight line, you have a curve, and then a straight line, then curve, and so on and so forth. Distance or station, it is not a straight distance from the start of your road. However, it is measured along the center line of your road. Hopefully, this is enough for you to know about the station. Now, let's look at the cross section because the cross section will tell you a lot about what we're trying to do. So here is our pipe. That's our project. We're trying to place and install this sewer pipe of diameter 1.25 meter. And remember, that is not a surveying information. We do not decide the diameter of the pipe in surveying. Somebody else will have to do that. Then we also have to leave a 1/4 meter on each side because it's impossible to make a trench exactly the same width as the pipe. I think this makes sense for you. Then the next part is we maintain the size of the excavation, which is this side here, and this side here, we maintain it vertical. And you guys know, soil by itself, it doesn't stay vertical, right? Then what we have to do is we add here a shoring, and then we add some cross braces to maintain those sides vertical. So what we do is basically we're trying to make a trench And the total width of the trench is very simple. It is the diameter of the pipe added to that clearance of 1/4 meter each side. So my total width of excavation is 1.75. Now look at this. Where is the existing ground? So my ground before I install my pipe, it was at this elevation here. Probably I'll give it different line type. So this is my ground, and my surveyor simply placed the rod and found for me elevation at this point here. Okay. Now a designer will simply do something else. We'll say, okay, let's put our pipe here at this elevation. And what do we call this elevation? Invert elevation. Again, there are so many factors, and it's not really our topic in surveying, because you guys know, you have enough information right now in civil engineering to know why this pipe is not really on the outside. Can anybody tell me, just to test you guys, why we don't really place the sewer on the top of the earth here?
It'll freeze.
Yeah, it will freeze for sure. Look at how lovely our weather is, especially this week and probably next week. We're getting minus 36 at night. So for sure, because this pipe will contain some fluid, it will freeze. And if this pipe freezes, this is a disaster by all means, because simply you will have a back sewer in your house, and that's a disaster. Okay, so that's a big deal. The other thing is can it be just like, let's say, 1 meter below the surface? I'm gonna save your time. No, it cannot be, because it has to be deep enough not to feel the traffic on the top. Otherwise, if you make your pipe shallow, then maybe the pipe will be broken, and sometimes we see that. Okay, especially for water main. Anyway, again, that's not my discussion in surveying. I want you guys to feel it, that we need to place this pipe at a given elevation by the designer. Now, my job here in the surveying class is to tell them, you know what, it will take you this, how many cubic meter to build or install the pipe of cut. Okay, so next part, to solve this problem, here is how we do it. We need to draw something called profile. Okay, look at this name. We're going to estimate the earthwork from profiles. And our first step to do that, we need to draw the profile. So here is your final product. So your profile at the end, after you do it, it will look like this. And let me show what does it mean profile. A profile is very simple. The profile is you simply cut through the center line of your project and then look from the side view. Cut through the center line of your project, then look from the side view. And look at this place. You will see here we have two lines. This line here in magenta, which shows you the change of the existing ground along the center line. So the ground goes up, down, down, and then up. So this is the change of my existing ground. Together with the existing ground, there is another line here in blue, which is the invert of your pipe. And so we call this thing a profile. Now I know that drawing the profile for some of you, it could be a very trivial process, very trivial, very simple, but I can tell you, for many of you, you don't know how to draw the profile the right way or to scale. Now I'm going to explain this in 5 minutes, and again, if you're sure that you know what I'm saying, you can just enjoy your time. Okay, my discussion within 5 minutes to show for somebody who doesn't know how to draw the profile in the right way. Now the profile in simple terms is simply a curve, a relationship between two different variables. On the horizontal axis here is simply the station or the distance. So we want to see how the elevation will change with the change of the distance from the start of your project. And simply this is a profile. Then really to draw any relationship, you must draw the grid lines. So I'm referring to these grid lines. So this line here and this line over there and all the horizontal line. How can we draw those grid lines with the right scale? Here is my answer. If you try to do the same thing on AutoCAD, that is a piece of cake. If you want to draw the profile on AutoCAD, that is a piece of cake, because in AutoCAD, we simply draw things to one. So if I have 25 meter, I'm going to go back and show you what was the spacing between our data. It was 0, 25, 50, and so on. So what does it mean? It means we have a spacing of 25 meter. So on your CAD, you want to draw the first line, vertical line, and then you want to offset this one 25 meter, and you can build all those vertical lines. Easy peasy. How about the horizontal lines? So you want to draw a first line, and then what you want to do is you want to offset this line by a distance, okay? So what happens here is typically this vertical grid line is at every 1 meter, and on AutoCAD, what we do is we multiply it by a number. Because why is that? I know the horizontal is straightforward. If I have offset of 25 meter, so you can see here 0, 25, 50. So that's easy. I draw the first line, I offset 25 meter. The vertical is a little bit tricky because we do not draw horizontal and vertical to the same scale. We have to distort the vertical scale. The reason why do we distort the vertical scale is to be able to see elevation difference. I want you guys to imagine, what if I don't distort the vertical scale? Can anybody tell me how the magenta line would look like if I don't distort the scale?
It would be like a straight line.
Exactly. You won't see any change in elevation. And I have a good example for you. You guys know between Calgary and Edmonton, what is the distance roughly? Not to the millimeter, just to a kilometer. About 300 kilometers. That's a distance between Calgary and Edmonton. You know how much the elevation difference between Calgary and Edmonton? It's only 300 meter. Please think about it this way. I want to represent 300 meter and 300 kilometer with the same scale. What happens is, if you go with the horizontal, then you see no change of elevation. That's why ever since highway engineers and designer, they always create a profile with distorted scale. What does it mean, distorted scale? It means I'm going to use two scales. That is unlike plan view. Plan views, they have the same scale. If you go any direction, plan views and maps, they have the same scale. Profiles, they don't. Profiles, they have a horizontal scale and vertical scale. Here is the universal rule. The people agree on this rule long time ago, and it's kind of universal, like almost every engineer or designer trying to create a profile will use this rule. The rule is very simple. You take the horizontal scale, you multiply it times 10. You can see here an example. Horizontal scale 1 to 1000, then the vertical would be 1 to 100. I'm going to ask you, what if the horizontal scale is 1 to 500? 1 to 500. Can anybody tell me what will be the vertical scale?
1 to 50.
Thank you so much. That's correct. Okay. And how this affects my drawing in CAD? Very simple. In CAD, all you have to do is you sub between these points in CAD, between these lines. I'm going to dimension it here. Between this line, in CAD, it's supposed to be 1 meter, just 1 meter. But guess what? Because we're simply using a different scale, on AutoCAD, we simply multiply the 10 meter by 10. So I'm going to draw a line and then multiply the offset by 10 meter. So on the AutoCAD, I multiply by 10. So I offset by 10 meter and so on. Okay. How about on piece of paper? So this discussion is on a piece of paper. How about this discussion was on AutoCAD. How about if I try to do the same profile on a piece of paper with the same scale? Watch this. So if you want to do this on a piece of paper, which you're allowed to do that, then I don't have AutoCAD. So simply I have to use the scale right away. And what happened here is, watch this. So we know that this distance in real life is how much? Between this point to this point. Do we know the distance? Yes, we know it is 25 meter. That is in real life. I'm going to move it here so you guys can see. So we know this distance in live in 25 meter. And if we're doing CAD, then we do 25 meter. I'm asking you, what about if we do it on a piece of paper with a scale 1 to 1000? Can anybody tell me what should be the distance in between the two lines on the piece of paper? I'll do it one more time here. I'm asking you, on your piece of paper, I'm trying to draw those two lines. Can anybody tell me how much?
2.5 centimeter.
Thank you, sir. That is 100% correct. So if you do it on a piece of paper, you want to do 2.5 centimeter because the scale is 1 to 10,000. Okay. How about this distance here between 110 and 111? This distance here, you can see between here and there, in reality, this is 1 meter. 1 meter. How about on paper? Let's do it one more time. Look at the scale. The scale is 1 to 100. So on a piece of paper, please understand that you should make two lines with distance of 1 centimeter. Why centimeter? Because 1 centimeter with a scale 1 to 100, it will be 1 meter on real life. Okay? Then so you know, once you're able to plot the grid, I can tell you, from this point on, your life is super easy. Because all you have to do is simply plot these points. I'll show you which points and then connect them together, and this will create for you the profile. I'm trying to clean things up so you guys can see better, okay? Now watch this. So just imagine that the grid is there and you don't have anything for so far for the magenta or the blue. Watch this. So you guys know that when at the first point, let's go ahead and go back to our data. At the first point where I have elevation is equal to 110.3 and then the station is 0. So all you have to do is go down here and at station 0, you go 110.3 and then simply you draw this point here, okay? This point here. So this is 0 distance or station plus 110.3. Next one is, let's go here. So the next one is 110.7 at distance 25. So I go here. So I go here on 25. I go up and I simply locate 110.7. And then so on and so forth. So you bought all these points, connected them together. It will draw for you your existing ground. How about the pipe? How about the pipe? So the pipe is a little bit needs some work, huh? Because we know that the elevation at the start, which here, 108.4. So on the pipe, I know only one point, which is here. The elevation of the pipe at the start, 108.4. How about the other points? Very simple, not very difficult. We will do that. I'm going to show you right now on how to estimate the elevation on the pipe. Okay, based on what? Based on the elevation of the start together with the long slope of your pipe. Okay, now before I do that, I want you to guys to imagine that or understand that. Look at this. At this point of time, do I have these numbers? So I'm going to cover these numbers. I'm asking you, those numbers right now, do I have them? I don't have them. I don't have the elevation on the pipe every 25 meter. All I know is I know the elevation of the pipe at the beginning, 108.4, and I know the slope is minus 0.4%. So which means all these numbers are not known. Now, can we do it? Can we figure out what's the elevation on the pipe every 25 meter? If I know that the start is 108.4 and the slope is minus 0.4%, can we do that?
Yes.
Yes, we can. Very simple, by the way. I'll show you an example. So I'm going to write my example here. For example, let's say I want to find the elevation here. So this number for me is unknown. I want to find it. Watch this. It's as simple as you say the elevation here is equal 108.4. This is where I start. And then minus, why it's minus? Because the slope of the sewer is downward. And I want to tell you something. All the sewers, all of them, they must slope down. Not a single sewer can slope up. You guys know why, huh? Why the sewers, all of them, they must slope down. Right? You know that. All the sewers must slope down because simply the sewer is kind of called open channel flow. It is not pressurized. And what does it mean? You must provide a slope for the flow of the fluids. Okay. So there must be a slope, and the slope must be down, just like rivers. I think about the sewer as a river because simply the river will have to slope down from the upper elevation to the lower elevation. So that's why it's minus. Now, the next one is the slope. How much is my slope? I'm going to write number, and please correct me if I'm wrong. I'm going to say minus 0.4, and that's the slope. Is that right or wrong?
Wrong.
Wrong, because the slope is 0.4%. The way I have it right now is 40%, because it's 0.4, it means 40%. However, the right way is to say divided by 100, because the slope is 0.4%. Finally, what you have to do is you multiply times distance. This distance is simply between the known point, which is 108.4, to the unknown, or the point that you're calculating, which is just 25 meter. And this will give you right away, will give you 108.3 meters. And what you do is you simply take this number, place it in the table. Let me show you. Okay, are we right? Okay, here we go. How about if I want to do the next number, which is this number here? I do the same thing. You know what? I'll just move my arrow, and I will show you. I'll move my arrow here, and I will show you. All you have to do is same equation. However, this number is, can anybody help me? This number is
50.
50. That's correct. Thank you. So we go here 50, and this number is 20. And then I can simply move my box, and you can see, good news, huh? You can see it's 108.80, 108.20. Okay, so this is one way, and I know all of you guys know this way is not super science for second year CVT, but I myself will have a different method. Not really science or anything like that. It's just my own method that it helps me to estimate elevations even quicker. And it's based on the understanding of the slope. Okay, so watch this, please. Can anybody tell me what does it mean 1% slope in plain English? Here is how it means. So a 1% slope, it means you go 100 meter. If you go 100 meter, then, and the slope is negative, you drop in elevation by 1 meter. This is the meaning of 1%. How about if my slope is 0.4%? Can anybody tell me if I go 100 meter, how much I lose in elevation?
Four.
How much?
4 meter.
Not really. It's only 0.4 meter. It is 0.4%. Look at this. 0.4%. 0.4. This is how we do it. So this line here slopes 0.4%. Let's write it down. 0.4%. This is the slope of the line. We go 100 meter and we lose 0.4 meter. Now I'm asking you, between the points, this distance which keep repeating, it's how much? Any help? 25 only. And what does it mean? It means we need to see after 25 meters. So here is my distance, 25 meters. How much do I lose? Can anybody tell me? So if I lose 100, I lose 0.4 after 100 meter. How much would I lose after 25, which is here? This is very simple, So how much this distance is?
0.1.
Thank you so much. Very simple. Because the 25 is a quarter of 100, then you lose quarter of 0.4, which is 0.1. And some of you will say, okay, Tahir, this is trivial. But you know what? Yes, this is trivial, but it saves you a bunch of time. Because watch this. If I apply the same thing here, and my distance is 25 meter, very simple. I don't have to do any of that. You can see I go from 108.4, I lose 0.1, I get 108.3, I lose 0.1, 108.2, 108.1, 108, 17.9, and 107.8. You can see just speeds up the results. But again, if you're not happy, if you're not comfortable with this method will save your life. This is okay. Okay. Now, I think it's time to break. So we remember before we break that we are able to finish and simply fill the table. Because after the break, we will continue and we'll continue on the table. Any question so far before we break? Okay, if no, I will see you guys in 10 minutes. We'll see you guys sharp back here at 1:05. Thank you.